Okay, are you ready to get building? On the last video I talked about this device that Heathkit made called a Q-meter. Their name for it was a Q-meter, model QM1. You can look this up on the internet and get the manual and the instructions on how to use or what the purpose was. But essentially the device helps you figure out what frequency a coil that you're going to need to wind is resonant at. You'll have some approximate turns, like, okay, I'm going to start out at 30 or 35 turns and I've got a 1/4 inch diameter form or maybe a 3/8 inch form. There are calculators on the internet that you can come up with that, but when it comes right down to it, you're going to want to know exactly what frequency the coil you're using you just wound, because there's differences in wire diameter, the way you wind the coil, like how close the turns are. There's a lot of factors that'll change the actual outcome or the frequency of the coil. So this was a device. I'm not going to build it as it is in the schematic. I've got a little bit simpler version, and the version I'm going to make is going to be the same circuits that you're going to use exactly, pretty much exactly. The oscillator and the buffer are going to be your local oscillator in your shortwave receiver. Now, I showed a couple chassis in the last video that was all spread out, and I've said I decided I didn't like that, how it was messy and spread out that way, and I've made it into, kind of rethought it and went into one little chassis like so. When I lay these out, and you'll want to do this too as a thought, when you're looking at it and you start working with your tubes and schematics are normally drawn from left to right. So V1 be on the left, and as you progress across the schematic, your tube numbers go up. And it helps having, when you have to troubleshoot or work on it, if you've got it upside down and looking at it, it should be pretty much the way it's laid out on your schematic, and that'll help you locate problems or missed wiring connections and stuff. I'm going to try to do kind of a step-by-step as best I can, and we'll get this thing wired up. This is what we're building. This is the first part. I'll leave this on here long enough to give some, if you want to freeze frame or do a freeze screen capture. These are only JPEGs, and at the end of this video I'll put my email address up if you would like any of these schematics or lists that I show. They're free. Just let me know. They're a small JPEG, and I can email you the JPEG to where you can print the schematic out and have it for yourself. I started out with the first coil on the other one. The coil I was using had 32 turns, 3/8 inch diameter, 28 gauge wire, and the tap was 12 turns from ground. And this on the other little rig gave from 5 to 9 megacycles. I'm going to want to lower that a little bit, so the first bands that we can cover with the Q-meter will be in the range of the 80 meter band, around 3.5 to 4 megacycles. So I'm going to change a couple things. I'm going to try to use the same coil, but I've since found a better capacitor. Instead of a 100 puff like I have here, I've actually found an old broadcast band transmitter. Lots of fins, and on the capacitance meter it measures 400 puff, and it goes all the way down to as low as 12. So I think that should lower that down. We'll see what it does. I may have to change the pattern, but I'll try to stick with the same coil. Okay, start off here. The first thing we're going to want to do is our filament pins. One pin of each tube will need grounded, and then the one pin from each tube will get a wire connected to it. So we'll start out with pin 4 of all 3 tubes, and we're going to connect that to ground. Now this is going to be tough, and I'm going to try to stay out of the way of the camera to where you guys can see. Pin 1, if you have the tube upside down and the gap is facing you, pin 1 is on the left, and they count in clockwise. So the opposite of pin 1 would be pin 7. These are all 7-pin tubes. So we're going to look for pin 4 and then ground each one. So 1, 2, 3. Alright, there's pin 4. Lean it out. Get some solder out here so I'm not short-leaded. Now I'm just going to poke this through that pin opening, because I'm not going to crimp this on the pin itself. And what that will make is so that I can undo this later and reuse this circuit if I choose to. So it's just laid through there. Now we'll get some, hope the sunlight isn't bothering. I got sunlight coming in the side of the window over here, and I hope that doesn't make a glare. We'll see how that goes. Okay, there's pin 4 of that one. Now we'll, okay, 1, 2, 3, 4. This is cleaned, bared copper wire. I've taken and scraped it before I started here so I could have some nice clean wire. That's why it solders so easy. Probably don't need to use this heavy wire, but it's what I had, so that's what we're going to use. Okay, and V3. There's pin 1, 2, 3, 4. All right, and we'll get him. There's another reason I love working with copper clad. You can take an SOS pad to it, clean it up, and just start soldering. You could use aluminum if you didn't have copper clad board. There's no reason we'd have to use copper clad. It's just what I had a lot of, and easy to solder to. Don't have to drill holes to mount like a little solder lug. Maybe that'll help. Forgot to turn my light up here. Good grief. Got ahead of myself. No wonder there was such a shadow. Alright. I might be able to do it. This one's gonna fight me. There it went. Okay. All right. Next, on the list, got that. Okay, where you can see that. That camera tipped on me. All right. So now pin 3. This is the other filament pin. We're going to hook a wire from tube to pin 3 of each tube. We're just going to hook them, and so they're all hooked together. We won't have to go back in there later and hook up filaments. They'll all be hooked up at this one time. We've got pin 3. Again, I'm not going to crimp that. I'm going to try to just kind of keep it loosely laying in there if it'll cooperate. Okay, there's that one. 1, 2, 3. So I go from there to here. I gotta get one more because we're going to go from that tube on over to V3. Alright, I think that I got it. Okay. And 1, 2, and 3. So we're going to come around. Well, this is going to be working behind the wall here. Let's see if I can get it. I know, I need bigger pliers, right? Okay, that's done and out of the way. Lay those all, get them all dressed and laid down. Okay, there we are, like so. Hope that's not glaring. A little bit up there. Anyhow, there's our filaments all wired up. Okay, now turn this around where I can see the back end of it. Next on the list is going to be the resistors and capacitors for V1. We're just going to hook up the oscillator for right now, and in the next video I'll go to V2. So here's what we got for right now. First thing we're going to do, okay, you can see R1 up there. That is a 68K half watt resistor. I didn't mark it half watt, but wherever these need power, like a little heavier resistor, I'll denote it and let you know. But for the most part, they're all going to be half watt resistors. Cool. So we got a 68K from pin 1 of V1 to ground. Pin 1, V1. And let's locate where that 68K is here. Alright, got him. Okay. Just solder it to the copper. That's ground. Okay, that's that one. Now we got a 100 picofarad capacitor to go from that pin 1 of V1 to the high end of L1. Now I haven't shown where L1 is at, but I've got a little, like a solder land here that I've carved out. I don't know if this camera will catch that, but there's actually 3 pads here. And I've done this so that I can take my coil and mount it clear at the back, and then I can unsolder it and change it, put a different coil on if I want, and it's out where I can get at it. So this is ground, and the high end is the top. High end of L1 is going to be there. So if you had a terminal strip, you could just bolt the terminal strip down or solder it, and where the lug goes to ground, that would be ground. And then all you need is 2 other ports on that terminal strip to mount the coil, however your coil is designed. Some coils, if you buy them as a normal coil form or like J.W. Miller, you can drill a hole in the chassis and they've got a little ring nut and a lock washer that'll fasten them down and bolt them to the chassis. But ours, the one I'm going to use, I could mount a hole. It's got a press fit type thing, but I'm going to need to change it as I go through different frequency ranges that I want to use, so I'm just going to mount it on the back. So the high end, where that goes. From pin 1 to the high end. And let's see, that was a 100 puff cap. Okay, I think I've got a, yeah, I've got a build one here. I think I've got one with long enough leads. Yeah. I don't think, do I? Oh, I might. Might have a little piece of solid wire here. Ah, I can make this easy. All right. I salvage a lot of caps from other dead equipment and check it with the cap meter, and if it's still good, why, try to reuse it. These things are getting to where they're about at $2 a piece. It's a silver mica. So even though it has leads that came through out of a printed circuit board, just attach some wire and get on with the getting on. Come on, cooperate. All right. All right. Yeah, that'll be long enough. I'm going to tin this, and then I'm going to poke it through that the hole in that pin. Alright, and we'll just lean it over. Kind of situate where it's going to be out of the way. I don't know, get the light on it where the camera can see that. Like so, and just solder it down. Okay, now our next on the list, pin 7 of V1 to the tap on L1. So pin 7 to the tap, which is the center land. This is ground, so the first one off of ground is tap. So from pin 7 to there. Boy, that ain't. See if I can prop that up where you can see what I'm doing. Almost need another camera looking over my shoulder, because that one looking straight down sometimes doesn't show everything. Gonna hang that in there and nail it down. Okay. Now form it to where it'll just lay down in there. Yeah, I guess the camera can see part of that. Alright, we'll get her soldered. Well, maybe go ahead and do it this way. Alright, that's that one out of the way. Well, that's next on the list. Alright, C4 is a 0.01 from pin 6 to ground. Oh, I didn't tell you what tube that was. We're working on V1. So from pin V1, from pin 6 of V1 to ground. This is So let me get the schematic and I'll show you where we're at. There we go. Pin 6 to ground. We're going to hook this cap right here to ground. That's what we're doing. So let's find a good one here. Find a good .01. This one has a little hook in it already, so I just got to open the solder away from it. Okay, 7, pin 6 right next to it. Squeeze in there. It'll lay right there. Now it's going to be another resistor going that same pin. Let's see if I can nail down the ground into this cap first to make it stand still. Nope, didn't work. Didn't get it. Oh, it's gonna fight. It's gonna give me a fit. I picked one with too short of leads. But we're gonna make it work. Promise. Alright, now I can get at it. No, I think it just scooted away from me. Alright. It's going to fight me to the end. I'll have to hold it with the pliers. Okay, didn't get away that time. Okay, now also on that pin is R2 68K from pin 6, and this is going to be our screen resistor, and I'll show you that on the schematic what we're doing. That's this 68K, and I've got this C810 is already nailed down up against the wall, so I'm just going to bring that resistor out and hook it to the end of it. Where that's at, this is already grounded, and this is the tie-in. This is where I'm gonna, when I bring my wires to hook it up to filament and ground and everything, B plus will come right to this point. So now I gotta find the 68K resistor. Okay, this one is a 2 watt resistor. 68K. See if I can. Don't know if I can hold all that together. We'll see what I get away with. If I can just tack it long enough here to bring it up to, I did it. There we go. Okay. Put a little curl around that, hold it. Now that'll hold it in place while I solder it. And I'll get this end nailed down. Okay, now I can go Make sure the bottom end is attached securely. And there it is. Okay, that's done. Alright, so where are we at now? Okay, the screen resistor's on. C4 is to ground. We just soldered that from there to there. So now, what's on the list? C5. It's a 200 puff. Goes from pin 5 of V1 to pin 1 of V2. Now we won't solder it to V2. I'm just going to go ahead and lay it in there because there's going to be another resistor in the next video that'll be attaching to that pin 1. So I'm going to go, boy, that sun's giving me fits here. I'm going to take the cap from pin 5 of V1 and hook it to pin 1 of V2. And what that is, this capacitor, and it just simply leads off the schematic, and we'll pick this up on the next video where I hook it to the multiplier buffer. Actually, it's just going to be a buffer amplifier on this application. So we'll get, and that's going to be another silver mica. And where's it at? Let's see. Okay, we just did pin 6, so pin 5 is next to it. I think, is that the right one? No, I'm trying to use the wrong one here. Almost. Okay. Pin 1. To pin 5. Alright, there that is. Now, there's another resistor that has to go there. Show it to you. We just hooked this capacitor to pin 5. And we have a resistor. It's a 15K 2 watt. I didn't have an exact 15K, but by selecting some resistors out of the junk box and comparing them, and with the tolerances that weren't exact on each one, these two resistors, which is actually a 39K and a 30K, comes out to about 16 measured on the volt on the ohm meter, which is okay. We're within tolerance of that. And these are actually 2 watts. I didn't need anything that big, but I didn't have anything smaller, so I just made up a resistor. And this is kind of one of the things I want to show you guys, that if you don't have the exact parts, start doing a little bit of math, get out the calculator or the ohm meter and just start seeing what you got. Put stuff together in parallel. Okay, so what we're going to do, it's this one, R3, 15K 2 watt, from pin 5 of V1 to the B plus point at C10. In other words, we're going to come back to that capacitor up there. And it's going to go right where we soldered that cap just a second ago. Hope it don't jump out. We're going to try to sneak that little pigtail into the slot that's already there. And we got away with it. Okay. That might not be, maybe. Can we do it? Bend that over there where I can hook it to that, join those two. Alright, that's where our B plus is going to hook up to right here. Okay, now hardware wise, we got one more thing to hook up. Let's see where we're at on the schematic. Okay, we've hooked up R1. That was the very first thing we ran to ground. And we have a capacitor that has to go from there over. Well, we did. Okay, my bad. It's already there. So we have one more thing that has to tie in, and that's our variable cap. Got to run a wire. Put it over here on the camera where you see it. Got to run a wire from this cap over to this point right here. We're going to try to use maybe what's left of this stiff wire to go there. Are we going to get away with it? Maybe. This is going to be tricky. I'm going to have to, didn't think about this far ahead. Got to prepare a place to solder it. I think I can get away with that right there. But to bear with me, guys, this is just out of view of the camera, but I'll be quick. And okay, now gotta put a little bit of a tail on that. I bent that wire just at about a 45. I need to come up to get around the frame. Okay, now I can bring it back to where you can see what I'm doing. Bring this around, keep it from touching the frame of the capacitor, and then right down here. Boy, I almost came out with a perfect amount of wire. Couldn't have done that twice. Alright, now we can solder that down. And that'll allow us to vary the frequency of that coil when we go to mount it. If you were using this circuit as a VFO, you wouldn't want to run the wire that long. It makes it structurally unstable and your frequency would drift a little bit. But all we're going to do is be reading a coil, so we don't have to worry about if it'll shift a little bit. Even the frequency counter will make that change. So there it is, it's solid. We're hooked up to that now. And I think we're just about, let's see what we got to clean up. Check our wiring. I haven't hooked the coil up yet. I'm going to go get it. And I haven't added this across the coil. This capacitor here, I'll choose after a bit. It's going to go just simply from here to ground. That's all it has to go. And you can, once the coil's on there, you can even change that. This would be considered what they would call a patter capacitor. It limits the top highest frequency that this is tuned to. So if you're, let's say it goes from 3 to 5 megahertz, and you didn't really need it to go clear to 5, say you wanted to stop it at 4, you could change this cap and lower it down so where when your variable was at minimum, this cap here would hold it right at 5, and then it would go from 5 on down. That's the way that cap works. And it also, this would be on, if it was a VFO, you would choose this cap with what they call a NPO, or a negative coefficient. Some caps, some ceramic disc caps, have an N number. That means that they'll shift capacitance given parts per million at so many degrees centigrade. And that's what you do if you wanted to stabilize a VFO where you didn't want it to drift. This is where you'd start working on it with different caps across to load it with caps that would tend to stay or hold the frequency stable even though the frequency shifted. Alright, so we've got our grounds done, caps done, and we're ready. Let's get a coil. I'll pause the camera here and hook this tube up and see what frequency we got. I'll be right back with you. Okay, got everything hooked up, ready to go. I've discovered I made one omission because I didn't have it written down. If you can see it here, forgot all about putting the ground on pin 2. So I went back and did that. Everything else though was hooked up. I ended up adding a 47. Gotta get my viewfinder over here where I can make sure I'm in the frame. There we go. Instead of the 22, I went ahead and added a 47, and it came out really close to where I want. It'll go all the way down to the low end of the 3 megacycles. So it'll actually go below the CW portion of the 80 meter band. Okay, so we will turn the power supply on. I've got the frequency counter hooked up there. I've got a 5 picofarad cap hooked to where that 100 puff cap that came from pin 5 to V2, I've just soldered to the end of that a 5 picofarad cap for a sample. I'm not sure, these little frequency counters don't come with a anything that says what their limit or max, so you might want to be careful anytime you're measuring something. Make sure you've only got just a real small amount of capacitance when you're taking your measurements, so you don't overload the front end. And here we go. We'll turn the power supply on. Give the filaments time to come to life. There we go, it's warming up. And there it is. Coming on at 3.8 megahertz. Let's see if I can close this capacitor all the way and see we bottom out at 3.3 megahertz. And we can still go all the way up. Let's see how far it'll go. 5, will it make it to 6? Yeah. Oh good. So right there. Yep. A little too high right there. So it made it into the 40 meter band. So now we can use this for 80, 75, and the 40 meter band. So that's just right. And that was with the coil that I had originally selected. Pop it up here again. See that in the, it's 32 turns, 3/8 diameter, number 28 gauge, and the tap is 12 turns from the ground end. So that coil worked just perfect. That's what we've got right here. This is the coil in there. Okay. Next video, we're going to, let's see, find the right schematic. What's the next one? What's the next one? There it is. Okay. It'll be the buffer circuit. This is that C5 that we talked about, and the pin 1 of the, or pin 5 of the V1, the oscillator. And since it's already hooked, when we come back, all we're going to do is we'll start right here with this resistor, hook it. But that's the next part of the circuit. This is a little buffer amplifier that raises our output enough and isolates us from the oscillator, so any changes we try, any sample we take, it won't make the oscillator drift off frequency very far. So thank you for watching. Move that out of the way. If you need to contact me, if you want any of the schematics, the JPEGs, send me an email and I'll shoot them right out to you. Thank you for watching. Catch you on the next video.